All right, two more multiple choice questions, and I believe these still allow the use of the calculator, and I believe that the calculator is frankly useless on both of these. So calculus loves to do that to you, put questions on the calculator section that you don't need a calculator for. So the first one says, actually they both say, which of the following improper integrals diverges? So you're looking for something that when you integrate and then evaluate the limit, that you get some sort of undefined situation. Limit does not exist, and therefore the improper integral diverges. So if we look at each of these, first of all, 1 over x squared we know integrates to negative 1 over x. But when we evaluate it from 1 to, and I'll just put in the infinity even though it's really a t there. If you plug in infinity, negative 1 over infinity is 0, and then plug in a 1, you get a number. So you will get a number from that one. E to the x in the denominator, when you integrate, goes to negative e to the negative x, and evaluate that from 0 to, I'll just put the infinity in for sake of argument, you get a negative e to the negative infinity, which is effectively 0, and then when you plug in the 0, you get out a number. So that's not going to work. When you have the cube root of x in the denominator and you integrate it, you'll get x to the 2/3 times 3/2. And it looks like this one I would have to split the integral between negative 1 and 0, and then 0 and 1. But if I were to evaluate this at negative 1, 0, or 1, I would get out a number. So that one will diverge or converge to some number. So the last choice of the 4 that were given, not none of these, is D, and this one is an improper integral because it integrates over a vertical discontinuity. So we have to split it into two separate integrals. So when I integrate the 1 over x squared, I do get negative 1 over x. And the first one I'm going from negative 1 to t as t approaches 0 from below. We're approaching from below, so we have that little negative sign here. And on the next one, we're approaching t from above, so we have the positive sign here. But in both of these separate integrals, as we plug in t and then t approaches 0 and we have a 0 in the denominator, when we have negative 1 over something so minute close to 0, we're going to either have infinity or negative infinity. So this guy diverges. Continuing on with number 5, same concept here. Which one of these diverges? I think we can start to recognize some of these. Like A, this is going to integrate to arctan, which we know from the graph of arctan, we have an infinite limit of pi over 2. So this guy is going to converge to some number. X to the 1/3 in the denominator, similar to C that we did above, this guy will also converge. X cubed plus 1, I don't even know how that integrates off the top of my head, but I do know this, is that when I integrate, I'm going to have something still in the denominator, some sort of x squared, say. Like if we ignored the plus 1 and just thought it was x cubed, we would definitely still have an x squared in the denominator when we integrated. And that's a really simplistic way of looking at it. But then when you are integrating from 0, when we're evaluating the integral from 0 to infinity, if we plug in a 0 to the denominator, we still have this plus 1, so we still have a number there. And if we plug in infinity into the denominator, we get out a 0. So this one will come up to some number. This one says e to the x plus 2, and it's a similar discussion to C. Sort of if you ignore that plus 2, which is far too simplistic to do, and integrated it, you would get to negative e to the negative x, and you would have a discussion similar to this guy up here. You would get numbers out when you evaluated the limits of the integral. The one that we will have an issue with is this one. When I integrate the x to the 1/3 underneath, I do integrate to 3/2 x to the 2/3, and the difference between this one and say B or C from above is that I have this infinity right here. And if I plug an infinity into this x to the 2/3, I'm going to get out a limit that is infinity or does not exist, which is why choice E does in fact diverge.